Machine learning. Deep dive into neural networks and backpropagation. Hello, scholars! Today, we are delving deep into the world of neural networks and backpropagation, and particularly focusing on the crucial role of activation functions within this domain. By the end of our session, you should be able to grasp the essential role of activation functions and understand how they contribute to successful learning in neural networks. Each neuron in a neural network receives weighted inputs, adds a bias, and applies an activation function to produce output. Without activation functions, neural networks can only learn and perform linear transformations. Activation functions provide the much-needed nonlinearity to the output of a neuron. This nonlinearity enables neural networks to learn from error corrections, thus optimizing the solution. There are several activation functions used in neural networks, each with its strengths and limitations. These include sigmoid, rectified linear unit, ReLU, softmax, hyperbolic tangent, TNH, and many more. The sigmoid function returns values between 0 and 1 and helps in modeling probability. Its generalized version, the softmax function, is useful for multi-class prediction tasks. ReLU is a widely used activation function that returns either 0 for negative inputs or the input for positive inputs. Its variants, such as leaky ReLU, parametric ReLU, pReLU, exponential linear unit, ELU, and scaled exponential linear unit, SELU, provide solutions for its limitations. Choosing the right activation function can greatly influence the performance and training speed of a neural network. The choice depends on the specific requirements of the task at hand. Backpropagation is a learning algorithm used to update the weights and biases in a neural network. It uses the derivatives of activation functions to compute gradients of loss function with respect to these parameters. While backpropagation can help a network learn, it may sometimes lead to the vanishing gradient or exploding gradient issue, depending on the activation function used. Solutions such as choosing different activation functions like ReLU exist to counter these problems. The activation function impacts the capability of the neural network to generalize or train. Some networks even use different activation functions at different layers for better results. So, in conclusion, the choice of activation function has a significant impact on a neural network's learning capability. Activation functions coupled with backpropagation play a crucial role in learning from the provided examples and refining the model over time. In our next session, we'll explore other key aspects of machine learning, such as regularization and optimization techniques. Stay hungry, stay curious, and keep learning.